I'm going to share today is a 3D solution design. So before we go to the PPT, first we see some cases we ever did in China. This is China, Singapore, Suzhou Industrial Park. And as we can check the information from the picture, there have the ground LED, and also there has a vertical LED, and two parts of the LED to blend a bigger screen. And of course, as a requirement from the end user, in this screen, we need to do the 3D display effect finally for the video display. So this is a final display effect after we finish all the job of the 3D solution. So if we can say the vertical parts and the ground parts already composed to a whole image, and by the 3D video source, there have finally have the 3D display effect. So let's move on. Let's move back to the very beginning when we get some inquiry from the customer. So what would the customer say if we ask what kind of the display performance he wants for his screen? So most of the time, probably you will get the answers as below. I want a bigger screen, and I want my screen have a high performance view. But sometimes we may get the answers like something special, but which I have, but some others don't. Actually, we get the answer like those answers here. These answers cannot actually make us have a clear idea in our mind what exactly the clients require. So we need to do some translate for all these answers. Let's see one by one. For the first, we want a bigger screen means we need to measure the installation space, and depend on the installation space, we need to select the suitable pixel pinch for the LED screen. And we have the space size, we have the pixel pinch of the LED screen. Also the cabinet size, we can calculate a precise big screen resolution finally. So we will know what's big resolution we will going to install in this space. And for the second, if he wants to have a high performance view for the screen display, how we can understand for that? It means we need to select the suitable IC for the LED module. And of course, the receiving card as well to make the screen have a higher refresh rate and the grayscale. And to buy the high refresh rate and grayscale to make screen have the better display performance in the color. So let's move to the last part. Something special, which I have, but others don't have. This actually is the most difficult part. So how can we make it? So special? How can we make it different with a normal screen in the market? As Sarah and Terry just mentioned in their PPT, we can do some irregular screen design, like to design some special shape of the LED screen, and we do some special video rotation, like just like the Sarah showed in her PPT. But compared to this irregular LED screen design, actually we have another way, which is much easier to realize something special for your screen. That is 3D. So compared with a regular screen, actually 3D screen solution is much easier, and much easier to realize. So let's see what we need to, if we want to go 3D solution way to make our screen different. The basic requirement for the 3D solution, actually we can divide it into two parts. First is about the 3D video source. We have requirement for the 3D video source. It's double frame, which is mean 120 Hertz. As we all know, for the 2D normal video, most of the time it's 60 Hertz. for the 3D, it's required 120 hertz. So if you guys know some basic knowledge of our controller, how it works, you will know if we improve the controller frame set to 120, accordingly, the controller loading capacity will have dropped 50% off. That is because the logic inside the controller work. So if the controller drop 50% of the loading capacity, if we average to the each ports and the receiving card same as well, there will have 50% loading capacity drop off if we use it for the 3D solution. So this is a requirement of the hardware. Let's say the requirements of the 3D video too. So in the market, commonly we can say that there have two modes of the 3D video. The first mode is a left and right mode, and the second mode is a top and bottom mode of the 3D video. And about the core devices, I mean hardware, the 3D solution need here actually it's only three parts. The first part, of course, as we already mentioned, if we want to do the 3D solution, we need a 3D controller. And now we already have two types of the controller supports the 3D function. M Control 4K and Nova Pro UHD GR. These two types of the controller already support the 3D function. And besides the controller, of course, here we need a 3D emitter to pass the 3D signal from the controller to the 3D glasses. And here we have the EMT200 to do this job. And the last part, of course, our 3D need have the 3D glasses to receive the 3D video signal from the 3D controller. So total these three parts to make a whole system about the main structure of the 3D solution. The 3D controller and 3D emitter and the 3D glasses. So let's say this is a simple 3D solution structure. And the PC gives the 3D video source out to the 3D controller and the 3D emitter to pass the 3D signal to the 3D glasses. And finally, there have the 3D display effect, which when we say the content by the 3D glasses to the screen. So this is a single controller 3D solution. Let's say, for example, here we have a screen which resolution is 1920 by 1080. It's a standard Full HD screen resolution. And if we want to do the 3D display effect on it, we have the 3D controller. And of course, as we all know, this 3D controller supports the 4K. And yeah, the video source out from the PC graphic by the 3D controller and the EMT200 3D emitter. It's a simple structure for a simple, small resolution of the LED screen to realize the 3D solution. But how about if the screen resolution going bigger? Let's say this is a 4K by 1K screen here, but our PC can only out the Full HD resolution, which is 1920 by 1080. So, as we all know, we still need the processor here to make some video source process to scale the video input in the processor to make it match with the resolution in the screen, match the video in exactly with that screen resolution. So as we can check, the 3D video source out to the G6, which is our processor first, and G6 to process the video source and make it scaling to the 4K. And so there has another question. We have already said the Full HD solution, full HD screen to do the 3D solution. We already say the 4K by 1K. How about here we have a 4K by 2K or 8K by 1K screen? We need to, how about if we want to realize the 3D solution in that? As we just learned from the basic knowledge about the 3D solution, for the 4K by 2K screen, if we display the normal video 2D, there has only one controller can work for it. But if we want to realize the 3D display effect, the loading capacity for the controller will drop 50% off. So for a 4K by 2K screen, we need two 3D controllers to load it. So if we use two 3D controller, how can we blend the video source in it? As we just mentioned, of course, still here we need a video processor to make the video source scaling in it by the video processor. So problem is here, how shall we map the DVI from the video processor, or we call the splicer, out to the controller in? Show it as just as normal we did for the 2D video, the DVI1 output to the controller DVI1 and the DVI2 output to the controller DVI2. It's like just like that. That's not like normal we set. Actually, for the 3D video, it's not. First, we need check the basic knowledge for the 3D, how 3D works. Before we learn the 3D video work logic, first of all, we need to know how the human eyes to see the real world. This is a demo video for our human eyes to see the real world. As we all know, humans have two eyes, left eye, right eye. Actually, there will have two images generated in our minds. We see the real world. The left eyes to generate the left side image and left side vision, and the right eyes to generate the right side image, or we call the right side vision. Then by our brain to compose a whole image in our mind, in our brain, which make us to have a real feeling for the real world. So that's how the human eyes to see the real world, the logic of the human eye to see the real world. And after we know this, so let's see how the 3D video work with our 3D controllers and the 3D glasses. Actually, the 3D technology logic is quite similar as our eyes to see the world. As we can see, we need to record our 3D video source 120 Hz. And when it's displayed in the big screen to display the 3D video source, we need our 3D controller to process or analyze the 3D video source, then transfer the signal to the 3D glasses to receive the 3D signal, then to make the human eyes to have the 3D vision in human mind by the 3D glasses and the 3D controller. As we can see, this is a whole structure of the 3D solutions. This video is left and right type of the 3D video source. And first of all, the 3D video source will go into the 3D controller, and the 3D controller, after finish the process and the analyze job, then the signal will be sent to the 3D glasses. When 3D glasses receives the 3D signal from a 3D controller, and our human eyes can see the 3D vision from the 3D glasses directly, which can make us have a real feeling for the 3D effect from the 3D video source in the big LED screen. So, as we can see the work logic here, Actually, there will be displayed two kinds of the image or video in the LD display, the left side and the right side. And the left side and the right side will be changed quickly. Only if they change quickly, which can make there have the real 3D display effect. That's why we require the 3D video source must at least 120 Hertz. So this is the 3D video work logic. Okay, as we learned from the video, 3D how 3D works actually is the 3D glasses will compose a left eye vision and at the same time with the right eye vision compose the two frame picture by the controller, and the signal will receive by the glasses. And finally, the vision will be composed in our mind. So there have the 3D display effect where we finally see the video from the screen by the 3D glasses. So here is a basic diagram about the logic 3D works by the video processor and the controller. We can say the left and the right parts video will be divided 4 parts by the video processor, and the left part is left 1, left 2, right part is right 1, right 2, and finally will be output by the DVI separately. If we use the 3D video source divided, we can see here, it will be divided by 4 parts, and the left controller will be just display the left part, and the second controller will be just display the right part. And finally, by the controller and the 3D glasses, it will be composed whole image, 3D image in our mind, 3D vision image in our mind. So this is the DVI mapping for the left and the right mode 3D video. It's just follow the logic here we just showed, left and right part. And this is a DVI mapping for the top and bottom 3D video. So after we finish the hardware job, let's see, we already set up the hardware, the emitter, the controller, and the glass 3D glasses. And we already finished the DVI mapping between the splicer and the 3D controller. So how to set up the software in software for the 3D function in our LCT software? We need to run our Nova LCT software, and we need to head into the sending card page and enable the 3D function. We need to select the video source format, and also the eye priority. It's not difficult to set for it. And after the setting job by the software done, then bingo, everything set down here. Finally, the project finished with a 3D display effect here. So this is a 3D solution today I'm going to share. And thank you all. Thank you for your listening.